Hey, old gentlemen, it's 4-5 today. All right, so we're going to go into factoring polynomials. So you guys have heard me mention this a couple times over and over again. We were doing trig and things like that, and I would just say, oh, hey, and then you factor this out, and then a lot of you guys would be like, I don't know what that is. Well, you're going to find out what that is. So factoring is basically rewriting a polynomial in a simpler form. Okay, so it's rewriting a couple of different terms in a way that is easier for us to use. We're eventually going to use it to solve equations, okay? So in order to factor these things, I'm going to give you a couple of ways to do it, a couple special cases here. The first way that you could do this is by grouping, okay? So this grouping thing is basically taking out the greatest common factor. That's why this comes right after the greatest common factor stuff, okay? Now take out, another word for that is undistribute, okay? Think of it as undistributing something, because you all know the distributive property very well. All we're going to do is do the reverse opposite of distributing, undistribute it, okay? Now these perfect squares, right, we've talked about these before. We talked about them a couple sections ago. Basically we were able to expand them using basically in the multiplication section, right? A plus b squared, it comes out to all this stuff. So if you have a squared plus 2ab plus b squared, you can factor it to be a plus b squared, okay? This is the simpler version, right? It's a little bit smaller, okay? And the same with a minus b squared. And lastly, we already know that this FOILing method, right, a plus b times a minus b comes out with a squared minus b squared. If you start with a squared minus b squared, you can factor that to be a plus b, a minus b. It's called a difference of two squares, okay? Now, lastly, these perfect cubes, this is probably something that's a little bit new to you guys, a little bit more difficult to understand. Okay, so if you want to factor a perfect cube, so this has to be a perfect cube, and this has to be a perfect cube. So you've got a cubed plus b cubed. You could use this formula here, a plus b times the quantity of a squared minus ab plus b squared. Now, you might think that this looks pretty similar to this, right? Well, what's the difference? The difference is this 2. Okay, so because of that, because that 2 is not here down here, this could not be factored to a minus b squared. All right, and ooh, looks like I made a mistake in the second one. Okay, if you've got a difference of two cubes, so that's a sum of two cubes. You have a difference of two cubes with a minus sign. This is supposed to be a minus. Okay, that's supposed to be a minus. Make sure you change that on your paper. So it's a minus b times the quantity of a squared plus ab plus b squared. Okay, let's jump right into some examples. So we got to factor these things. All right, the first way, remember, like I mentioned, is to take out the greatest common factor. Okay, so you could go through all the greatest common factor stuff that we've been doing recently, but you might not need to necessarily do that. You might be good enough now at this point to recognize greatest common factor. So you find the greatest common factor between these two things, and you pull it out. You undistribute it out of your polynomial. Okay, so for this one, greatest common factor between 24 and 40, hopefully as you break these down, you would come up with 8. Okay, 8 would be the greatest common factor between the coefficients, x and a y. Okay, so 8xy should be what you came up with for the greatest common factor. Now, basically what's happening here is you take that xy out of this polynomial, that 8xy, and what you write inside is whatever's left. Okay, so if you take 8 out of 24, you're left with 3. You take an x out, you're left with x. You take a y out, you're left with nothing. And for the 40xy, you take an 8y, you're left with 8 out, you're left with 5. And the x and the y come out, so it's by itself. This is a factored, simpler form of that polynomial. Okay, it may not look that simple right now, but it will be much easier to help you solve equations. Second one here. Now we're going to get into some of those special versions. All right, so hopefully you'll notice here that x is like a, okay, and this back here would be your b squared. Okay, so if x is a, we got a squared plus 2ab, okay, plus b squared. Well, b squared here would be 49, so b would be 7. Well, does 2 times 7 make 14? Yes, it does. So this is actually in the form a squared plus 2 times ab plus b squared, right, where b is 7 and a is x. Okay, so we could simplify this factor it to be x plus 7 quantity squared. Okay. Now, next one here, we've got 81 minus 4a squared. Well, you got to notice here, if you have something like this, if you see that both terms are perfect squares, which these both are perfect squares, you could take the square root of both of them, then that is the difference of two squares. So the difference of two squares could be always broken down into, right, let me write the whole thing out in case you forgot it from the last page. So this is a squared minus b squared could be rewritten as the quantity a plus b times a minus b. Okay, so we just got to figure out what a is and b is. Well, a is just the square root of 81, which is 9. And b, there, is the square root of 4a squared, which is going to be 2a. So 9 plus 2a, 9 minus 2a. That's the factored version. Okay? Next one. Got a cubed minus 8. A cubed minus 8, we need to see if there's anything special there. Well, since we see the a cubed, it's probably going to be the difference of two cubes. So you could go back to the formula we wrote down last, on the last page, and we'll see that this can be rewritten basically as a to the third minus 2 to the third. Okay, so you see a difference of two cubes. A is a, and b is 2. Okay, so when we write that out, we're going to get a minus 2 times, remember, a squared plus ab, which is going to be 2a, plus b squared, which is 4. Okay? Now, if you expanded this whole thing, if you did that multiplication, you're going to end up reducing that to be a cubed minus 8. Number 5. Now we get into a little bit more difficult problems. Those those four are pretty simple, right? Once you understand how to use those formulas. There's a little bit extra step involved. Maybe you're using 2 of them, or you got to rearrange or something like that. So in this first one, you can do grouping, even if it's not grouping from the entire polynomial. What you could do is you could split this up to look like xy plus 5x plus 3y plus 15. Okay, now you could just take out the greatest common factor from each of those and make two different things. So the greatest common factor here between xy and 5x is just x. That's all they share. Right? Greatest common factor just means, what do they share? What's the biggest thing they share? So you're left with y in the first term and 5 in the second term. Okay, when you do this to the second one, the greatest common factor there is 3. And when you take 3 out of 3y, you're just left with y. When you take 3 out of 15, you're left with 5. Now, hopefully you notice that we've got a y plus 5 in both of our terms. So now we could take the y plus 5 out, because that's the greatest common factor between the two terms that are left. So you take the y plus 5 out. Okay, you're basically undistributing it out. Okay, you're factoring it out because it's the greatest common factor. And what you're left on the inside, when you take y plus 5 out of x times y plus 5, you're just left with x. And in the second term, when you take the y plus 5 out, you're just left with 3. So y plus 5 times x plus 3 would be the answer there. Okay? I know that one's pretty tough, but these are just some of the more challenging problems you'll run into. Now, this next one. Okay, sometimes you'll group first, and then you'll find you're left with one of those special perfect cubes or perfect squares. So for this one, let's start with grouping. Just pull out the greatest common factor, which is going to be 2u. You could take a 2u out of both of them. So you're left with a u cubed in the first term, and you're left with 27 in the second term. Now, hopefully you see here that u cubed plus 27 is the same thing as u cubed plus 3 cubed. So we've got our a and our b, and we can continue on from there. We can expand that. So we leave our 2u. Now, since it's a plus, we're going to have u plus 3 times the quantity of u squared. Remember, it's minus ab minus 3u plus 9. This is the factored version. Okay? And lastly, this one's a little bit tougher because you've got multiple different variables and exponents. Okay, but you could recognize here that this is actually the same, this is written, all right, in the same way as a squared minus 2ab plus b squared. Okay, I know it's tough to see that, but let me show you what that looks like. Where a here is just 2m to the fourth. Okay, so 2m to the fourth squared minus 2 times 2m to the fourth times b is actually going to be 3p to the third, right? 2ab plus 3p to the third squared. All right? Like I said, I recognize this is very difficult to see. So these types of problems, these 5, 6, and 7 ones, are ones that you really have to play around with, and you got to try some things, and you're going to mess up and go back and keep trying. Okay, so because of this, you see it's a squared minus 2ab plus b squared, right? 2 squared is going to be 4, m to the fourth, right? Because you multiply a power to a power. We've got 2 times 2 is 4 times 3 is 12, so that's our minus 12, m to the fourth, p cubed. And lastly here, 3 squared is 9, p to the third squared is 6, because power to a power means you multiply. Okay, so this whole thing, right, we know that this a squared minus 2ab plus b squared factors to a minus b squared. So the answer here is going to be our a, which is 2m to the fourth, minus b, which is 3p cubed, quantity squared. That's supposed to be to the fourth. Okay? That's one of the more challenging ones. Good luck, guys, and I'll see you in class.